All right, this is going to be Unit 12, Lesson 2. This is the second video. Sorry for having to make two, but I wanted to fully discuss this idea of outlier. Previously, we've discussed outliers, a point that's particularly below or particularly above a set of data. Well, notice that this is referred to as a minimum and this point over here is a maximum. In order to be considered an outlier, it needs to be 1.5 larger than the interquartile range. So in order to determine whether a point truly is an outlier, not just a point that's higher or lower, we need to find the interquartile range, which means you're going to have to do your work for a box and whisker, multiply the interquartile range by 1.5. You'll add the number to the upper quartile, that'll give you your higher outlier referred to as the upper fence, and then you'll subtract it from the lower quartile, giving you what's referred to as the lower fence. If a data point beyond this if a data point is beyond these values, then that point is truly considered an outlier. So for problem 6a, we have the same exact set of data as we did in problem 3a. So what I did was I copied my work so that I didn't have to do all of that over again. So what we had calculated was that the lower quartile was 8.5, the median was 12, and that the upper quartile was 14. So that means the interquartile range is when you subtract the upper quartile from the lower quartile, which when you do that, you end up getting that it is 5.5. So the amount of numbers, whoops, that's my little, oh well. So the amount of spread between the box here is 5.5. So what we're going to do is we're going to take 5.5 and it says multiply the interquartile range by 1.5. So 5.5 times 1.5 is going to give us the allowable fence that we can have for an outlier. So grab your calculator, and I got 8.25. So that means if we take this upper quartile and add 8.25 to it, then that means the higher fence is 22.25. Meaning here's 20, here's 21, here's 22. So if a number is higher than this 22.25, this upper fence, then these are all of your values that are outliers. So even though 20 is your maximum point, it's not statistically considered an outlier because it is within 1.5 of the interquartile range. Let's do the same thing for the lower. Let's take that 8.25 and subtract away from it our lower quartile, which is 8, and I end up with 0.25. So that means the lower quartile is going to be, or I'm sorry, I don't mean lower quartile, I mean that the lower fence is going to be way down here. So even though 5 is the minimum value, it's not technically considered an outlier because it falls within 1.5 of the interquartile range. So the question says, determine if the data contains an outlier. Which measure of central tendency would be appropriate? So here, because there are no outliers to this particular set of data, think about measures of central tendency. We have mean, and we have median, and we have mode. Mode is appropriate when the data deals with a category. That's not what we're working with here, so mode's not appropriate. Mean is appropriate when there is an outlier. Median is appropriate when, I'm sorry, I have this the other way around. Median is appropriate when there is an outlier. Mean is appropriate when there is no outlier. It's not the greatest way to remember it, but I think about mean, which is average, that if I wanted to add up all of my test scores and divide by how many students I have and find the actual average of a set of tests, if I have one student who does particularly low, or let's say I have a student who cheated and has to get a 0, then that means that that one student is going to pull everybody else's average down. So I don't want to use mean when there's an outlier because it's going to affect the mean. The idea of median is that's when we line everything up and we find the middle. So that student that got a 0 isn't going to affect the median. That student who got 102% isn't going to affect the median, and you'll find the perfect center. So because there are no outliers in this set of data, I think the best measure of central tendency is going to be mean. All right, so here there's one more. It says determine if the data contains an outlier, which measure of central tendency would be appropriate. So these how-to steps. We need to start by finding the interquartile range, and to do that we essentially need to set up this box and whisker, although you don't have to graph it. So let's arrange things from the lowest value, which is 3, all the way up to the highest value. So there's a 4, there's a 4.2, another 4. Eek. Let's squeeze all these in here. A couple of 5s, the 6.5, and the 8. All right, so to find interquartile range, we need to find our quartiles. Start by finding median, which is the middle. So cross those off, cross these off, keep going until we find the middle. So the median is going to be right in here. So add up 4.2 and 4.5, and the median, well, I guess we really don't even need to find it, because for the quartiles, we're really just dealing with the, so if this is the median, so this is the lower quartile, and if that's the median, then this is the upper quartile. So it says find the interquartile range. Well, the interquartile range here is that 5 minus 4, so my interquartile range is 1.0. I'm going to take that 1.0 and multiply it by 1.5, so it's 1.5. Add this number to the upper quartile. So if I were to take the 5 and add to it the 1.5, I'm going to get 6.5. This is my upper fence. Anything higher than this number is going to be considered an outlier. Now, take that number and subtract it from the lower quartile. So 4 minus 1.5 is going to give me 2.5. And this is referred to as the lower fence. So any number that is below 2.5 is going to be considered an outlier. Everything out here is an outlier. Anything higher than the upper fence is also going to be considered an outlier. Think, for instance, outfield. Not really outfield, like out of the park in baseball. So anyway, bad analogy. What's it asking? Let's read this. Determine if the data contains an outlier. My lowest point is 3.5, or I'm sorry, is 3. So because it's falling within the fence, this one is not considered an outlier. But look at the next one. The highest value here is an 8, which is outside of that upper fence. So this one is considered an outlier. So does the data have an outlier? Yes, it does. So which measure of central tendency would be appropriate? Well, thinking again about mean, median, and mode. Mode is not going to be appropriate because it deals with categories. Median is when we line everything off and we find the middle. Mean is with that idea of average. So those really low scores and that really high scores are going to affect my average. So this is when we have no outliers. We can have outliers with median because we cross everything off. Those really lows and those really highs aren't going to matter. So in this particular case, because yes, we have an outlier, median is going to be the most important. That concludes the second video on outliers. Thanks so much. Let me know if you have any questions.